G'day everyone, today I'm going to be working on this front fender for my 1934 Ford. Now over the years it's had a fairly rugged sort of a life, and there's this big crack that runs all the way through here and down the side. Now we can only imagine today in our generation what the roads were like and the conditions were like that these cars saw every day way back in the 1930s, the 1940s and the 1950s. So those conditions have led to this damage, and someone's repaired it in the past by riveting a big piece of steel underneath it. Now I'll just grab that. Now in the past somebody's pounded this into a rough shape of the fender and got a bit of a curve in it, and then they've put it up underneath and they've put a sequence of rivets in here to tie the crack back together. Now clearly the car was driven with this fender flapping around all over the place because the spare wheel well has dropped down and it's rubbed on the tyre, and also this front inner edge in here has been rubbing on the tyre as well, so that's worn away as well. So there are other jobs to do. It's also had some welding repairs which were probably done at different times to what this repair was. I'm guessing that whoever repaired this part of the fender didn't have welding equipment or welding skills. But when they've welded it together, there's a little bit of a misalignment there, so we're going to have to wind up cutting that and then realigning that as we go. There's also some other places down here where it's been welded in the past as well, and the same thing, the fender hasn't really been lined up that well when they've done it, and I'll have to work that, but I'm thinking I might make a whole new piece for down here and come across there and go from there. Now I've had a couple of little goes at spotting this together, trying to piece together the little bits of the jigsaw and pick a spot so I can get a tack in there, but having played with it a little bit and having moved it around, I've decided to just chase the crack, start at one end and work my way through, and I think that's the best approach. In addition, they've made this big brace, and that was bolted on the inside of the fender around there, and it anchored on the front bumper bracket as well, just to support the fender. And the other side of the same car has the same brace on it. So somebody, probably a blacksmith back in the day, fabricated this bracket to try and keep the car alive for a few more years. Now the poor old dodgy dog's a bit upset today. It's a little bit thunderstormy outside, and he's the biggest wuss dog there is, and he's absolutely afraid of thunder and lightning. So he's going to be wandering around, getting in the way today, but we can live with that. Now you might be wondering why I'm working on a front fender when all of the focus so far has been building the ute body at the back of the car. Well, it's pretty simple. It's all for alignment. Now I'm learning with Model 40s. This is the first one I've built in a major way, but I've done a lot of work with Model A's and other 1920s cars, other 1930s cars, and it all comes down to fit and finish and alignment. Now every component relies on something else on this car to align off it. So I started out with a basic damaged cowl and I'm building a body from scratch, but I've got no real way of knowing exactly if this cowl is standing straight up and down or in exactly the right spot without the front sheet metal on it. Now this cowl came off a car that had been channeled. They'd cut all the bracketry off and dropped the cowl down over the frame rails, and I've reconstructed the little pieces I had left back into what I think it should be. So there's no guarantee that we're not actually tilted a little bit forward, tilt a little bit back, and we could even be in exactly the right spot. So I need to assemble all the front sheet metal on this car, the side panels on the hood, the bonnet, and the fenders, have them bolted to the frame rails, and I need to repair the damage in the fenders enough to get them back into the basic shape. And that way I can bolt everything together, make sure my grille fits the front, come back here, make sure the cowl's in the right spot, and that way I can set my door posts straight up and down, straight behind the door. My hinges are going to line up, and with these cars there's no actual up and down adjustment on the hinges. The door lines up on the door post, so if I set my door post too low or too high, it's going to muck up my door clearance around the roof and under the cowl as well. So there's a whole big picture going on with just sort of getting this part of the car assembled. Now since I saw you last, I've done a bit more work on the door posts, and I've been making these liners to go inside them. So this inner piece in here is new, and it's got this little recess down the edge here, and that's where a tacking strip's going to go in it for the upholstery to attach to. Now these old cars, the upholstery doesn't clip in, it's nailed into the car, and originally they had like a rolled up paper tacking strip that was clipped in, and the original style that used this, the steel had little legs punched out of it and opened up, so they just formed little tabs that were about 2 inches apart, and the people putting them together would put the tacking strip in and just hammer those little tabs down to lock it in place. And then when the trimmer came along, he'd come along with his tacks and just nail into that little strip. So we're going to do a similar thing, but because I'm not going to punch out little tabs, I'll probably put these in with little screws or something like that just to hold it in, and that way then when it's time to trim it, we've got a tacking strip in place. I've also got to set the foot for the bottom of the post in place. Now that's why I'm coming back to this sheet metal alignment, because I want one go at this. I don't want to be putting it in with the post too high or the post too low. I want to get everything lined up, make sure it's all going to work, and then it's going to go in. It'll fit on the frame like that. We'll drill it through and bolt it into the chassis rail with a countersunk bolt in the corner there, and that's going to be perfect. So from that point, we can then go back to building our ute body on the back. Come on, come with me around the other side. Okay, the behind the scenes stuff I've been doing. I've made a new crossmember rail to run through here that sits on our little tubular crossmember, and it's exactly the depth I need for the quarter panel to run down the extra 3/4 of an inch of height that I'm giving the car. And I've got everything sort of set up and screwed together, and it's all turning into being pretty solid for the stage I'm at. And let's face it, vice grips holding the corners, tech screws, and I've got a few bolts. I've got the fender in location, and I spent a lot of time on that, and I wound up actually putting 2 Roadster ute quarters on this car and playing off that. That's why the seat back's in there. I had it all clamped together and bolted through the original bolt holes just to sort of see what was going on, and I've rearranged a lot of stuff, and I've wound up moving the fenders a little bit further forward on the car to where I had them previously, and I've got everything to just sort of line up, going with measurements that I knew from other cars was going to be accurate, and I've got the flow of the fender looking really nice. Now I've said this before, Ford Australia squashed the back fenders up a bit on these cars. They sort of curled them in, and that was so they could tuck them up a little bit higher on the car and get a little bit more clearance over the wheel. Now if you were buying a ute new in 1934, the things you'd be looking for would be the carrying capacity, the size in the back naturally, but you also wanted to know that the car was going to be good for the rough roads it was going to encounter. Now the Aussies back in the day wanted to see plenty of ground clearance, and they wanted to know that this car was going to carry plenty of weight. So that big gap between the back wheel and the fender was what they wanted to see. Now I'm not that worried about that because this car's never going to carry a load, but I've got the dimension right. Now on the original ute body, it's 10 inches from the top of the side here down to the top of the fender, and I've got that exactly right. But to achieve that, I've let the fender curl back a little bit more at the back, and it's lifted a little bit higher than where it would be on a sedan or a coupe body. But that's fine, it actually looks really nice on the car. When you stand back, the wheel's well centered in the opening, which is a big thing for these cars. How often do you see a really nice looking 33, 34 Ford, and then you look at where the back wheel is in the fender opening and it's sitting right at the back or right at the front? So I'm really happy with how this car measures up now. We've got 19.5 inches from the front of the fender to the door opening, which is bang on the money for what the Roadster ute body is, and that's the dimension I'm using because my doors are going to be longer. The other problem I had was that if I put this panel on here to simulate the quarter panel and then sighted from the front of the car, it looked like I had a kink in the bead line. And surprisingly enough, the problem was the bottom of the pillar. I had it too far out on the car. And even though my rocker panel line looked really nice, it swooped down off the cowl, it ran through into the back fender, I had way too much bulge in the middle of it. So I left everything alone, disregarded this, and then I pushed the pillar in and I kept moving it in until I got this nice sweeping line off the side here. Now, I've got the Roadster ute back cab wall in here, so I do know that on the original body, this was the distance that the quarter panel was from there. When I look at the original ute bodies, the wooden pillar here, I've got a measurement across that, and it's what I've come to in here. So they pulled the wood around the back panel and onto the door post, and when it was all bolted and screwed together, there was a twist in the wood as it came around. So I've had to do the same thing. I've put a twist in this lower panel, and I've got it all to line up now. And I will be making a new one of these, because since I've shifted the fender, I've had to trim a piece out of the back here, but I'll make a little piece and I'll weld it into this one, and that way I'll have a pattern to make a new one in a single piece of metal. But that's enough of this. let's get into doing some gas welding. That'll be fun. Okay. Now, I used to do a lot of this type of welding, not so much now, but mainly because with selling your time, this is a very slow way of welding anything, but it does make a very nice join. And you've got to spend a lot of time working it as you go. The problems we're going to have here is the weld is going to want to shrink, and it's going to pull this panel in and get it to overlap. So what we'll be doing is welding a piece, and then we're going to be working the metal, spreading that weld back out and getting this join back to sitting together, and we'll continue on like that. And I'll just talk about it as we go. It should be all right. Now, I've been welding like this since I was probably about 11 years old, around about the time BMX bikes first came on the scene. And I couldn't afford a BMX bike, so I wound up cutting up a 20-inch push bike frame and making my own. And I rode that bike until I was in my early 20s, and don't have it anymore. Wish I did. It got thrown away. Now, we want a neutral flame with equal pressure, which is what we've got. We need a pair of goggles, and the plan is to just melt the two pieces of metal back together. Now, this panel has been driven broken. The metal's been rubbing away on itself, so it's worn thin on the edges in places. It's also had that other piece of steel riveted onto the back of it, so in spots it's actually even rusted through. So we're probably not going to get a perfect run. We're probably going to get a few spots like that where it'll blow a hole in it just because the metal's either rotten or it's just too thin to weld. So we'll get into it and just see how we go. So what I want to do originally is just put a little tack ahead of where we are and let that cool, and that'll pull this little gap in place in together there. We'll get another tack in, and then we'll weld up to the first one and keep working our way like that. So, now they've got to be touching for it to tack. And there we go, it is thin, it made a little hole in it. And I've got the paint scraper just holding the two pieces apart here so that I can work them. We need everything handy. So I've got a little rack to hold my fire on, and I've got milk crate for the hammer and dolly. Didn't like it. Got a gap again. Now the problems come in with damaged metal is as soon as you heat it, the expansion in the metal wants to lift the pieces apart. So could have a few issues just getting it to start. Yes. That's got it. Righto. Now over the years I've had people tell me different ways of doing this, and I've tried them all. Now one theory is get your bits of metal fitting exactly, and that's more if you're doing a patch rather than a repair like this. And then with them fitting exactly, put a couple of tacks ahead of where you are, weld your first one, do another tack, weld to your second one, and so on, and work your way across the panel like that. Other guys say that it's okay to weld with a bit of wire and then hammer it as it's cooling, and the term was actually called hammer welding for quite a while. It was pretty common in the 60s and the 70s, probably back to the 1950s, and the theory was that while you had it at the red hot state, you could get in there with a hammer and dolly and work it like that as you went, and as it would cool down it would stay straight. So everything works. Like if you read about it in a book, an older book about how they used to do it, there's multiple ways that you can actually do this sort of repair, and they all seem to work. But same as any other welding, just stay in control. Just if your panel starts doing strange things and getting out of step with where you are, let it cool down, work it back to where you want it, and then start moving again. So, like I say, we're just going to chase it. We'll just go with where it wants to go. And we'll probably do a combination of several styles, if I can do it without burning great holes in it. Naturally, when you're welding with a piece of wire like I was then, it's no different to welding with a TIG. It's just our heat source is different. What I've got is a little bit of an overlap just in this section in the middle here. So by working this area here, spreading it out a bit, I can open it out again. It's better. Thunder and lightning, very, very frightening. That was a big one.
I saw the flash.
Yep.
And I thought that's weird.
Yep.
And then all of a sudden.
Now, by keeping it pretty much roughly in line as I go, I'm saving myself work later on. So it's just a matter of tapping away with it. Now, there's quite a bit of heat in the panel now. I'm just letting that cool down, and naturally as it cools down it's going to pull this together. So we'll let it do that, and then we can weld a bit more. Now, just the same as with any other automotive welding, don't be in a panic to get it done. Just go with the flow, let it do what it wants to do. Keep tapping it back into line. Now, as it's cooling down, it's pulled a dent into it here, but this area was quite dented to start with. I've done a bit of work in there just lifting some of the stuff up beforehand. So it's just old damage that, now that we're sort of relieving the stresses in it, it wants to pull and carry on. I was told a long time ago, the real trick is knowing when to take the heat away rather than when to put it on. And I've got to agree with it. Now I've just got the dolly sitting on top of the fender brace, and I've just been sliding it to where I want to do any tapping and bits and pieces, and then pulling it out the way when I'm ready to weld. Getting a little bit hot. Could stop anytime I want.
Just curious about the workflow.
Yeah. No, with this sort of setup, we could stop it today, come back next week even, and just continue on with it. It's just going to cool and shrink back to where it wants to be. And if it's shrunk and pulled in, we could just sort of hammer up any of the spots. But what I've got, and this will be to do with the damage that the fender's had from rattling around over the years, a couple of little overlaps there. Now I could grind them back, tap them up. I'd rather shrink the metal and get it sitting in there. I've also got this spot where I've tacked it, which I think's also pulled it out of alignment, and it's not letting me get this piece here sitting in. But it's a tough call as to know what's happened from road damage and what I've caused by tacking this area up here before. I was just seeing if I could wriggle it around and get it to sit in place. I've got a rotten patch there, I nearly poked my thumb through it. Now, what will happen, we've got a rotten area just in here, and we've got a rotten area through here. For now, I just want to get this fender intact, back to all the original dimension, and then I can use it for my alignment. When we come back and repair it properly, I'll probably put a piece through here, get rid of all of the sad bit of metal in here, put another piece in there. Don't know that I could make it in one go, it's probably too big an ask, so it's probably two pieces to do that. And this is all pretty good metal down here, so I'd say that'll stay in the panel. We'll just repair that. We'll have to put a bit around the headlight naturally. So, but for now, I'll just keep faffing with it and get it to where I want it. Now, being that it's a curve, if it's a little bit tight, we can just lift the two edges until I want to sit together, and then once they're butted together I can weld them, and if it winds up being a high spot I can just shrink that back down later on. So The big thing is just not having that overlap in the metal. So, and it's right where the fender brace is. If I take that out, it'll probably be a bit easier, but it's holding the fender up at the moment. So. Too much heat melted the hole. I've got most of the way across the top now, and I'm just coming up here, but the little mismatch that they've got when they've welded it up, and you can actually even see it there, there's a big step in it, probably 3/16 of an inch, where this one's raised up against the back piece there, and that's starting to cause a problem for what I want to do. So I'm just going to split their weld and let this area float. Now I couldn't have done that before because all of this would have just flopped all over the place, so I've been relying on their old weld to hold it in line for me until I've got this far. Now I've also got up to a spot where it's quite rusty, and that's due to that other piece of metal that was under there beforehand. So there's going to be a few spots I won't be able to weld, but for now it's going to put the integrity back into the fender and I can use it for my alignment purposes. And then when I'm ready to use it, I'll actually cut all this away and make a new piece for it. So we'll slice it and go back to welding it. I'll try and follow where they joined it, which has got a little bit of a dog leg in it. Whoa, now she's a bit floppy. Imagine what it was like driving with all this broken and to getting it to the point of somewhere to repair it. Like, it must have been just flopping around all over the place. And like I say, the weld for the spare wheel's all worn away where it's dropped down on the tyre, and the front piece in here is all worn away where it dropped down on the tyre. So yes, the things that happened back in the day. trying to lift the crown up a little bit there to get the gap to close up over here, which it's doing that. It's just a matter of deciding the best place to hit it. Naturally, where it wants to sit back together, the fender will be getting close to the original shape. So I've got a spot there where I can put a bit of weld on that, and then I can start working around the corner. And hopefully, the piece of metal is strong enough to weld. Now you might be wondering why I haven't really worried about cleaning this up, grinding any paint or rust away. Well, yes, you do run the risk of a little bit of contamination in the weld from the rust. But many years ago, I made a good amount of money welding up motorcycle exhausts for dairy farmers. Now these guys would run their farm bikes through the slops after their dairy cows. Not only did the exhaust systems rot away from the inside, they rotted away from the outside, and then they learned that young Robbie Teal could weld exhaust pipes back together. So I spent a lot of time welding a lot more rotten stuff than this. And after a while, you do learn a few little tricks. One of them's to lay the torch down rather than point it at the piece of metal. I was just trying to get enough heat into the metal there to get it to expand to the point where the two pieces would touch. And it's done it. I've got a little tack in there. It's not very strong. You just tap him up a little bit. Little jigsaw puzzle tab was just there, so we knew that's where that one went. Now naturally, when this broke, it would have done this a little bit, so there's natural to have a little bit of wear, and some spots just aren't going to come back together. And I've got a little crack just in there, which is probably one of those, and that's why I spotted this piece, because I could see by the shape of the break, that's where it belonged. It doesn't matter. If we've got a gap at all, it won't work. It's actually got to be touching, but because I've heated this, naturally it will spread the piece of metal in there. Wait for a little while and let it cool, and it should touch back together. Well, it will touch back together. We know it will because we've played these silly games before. Now we've got that little suspected wear gap there, and by stretching the metal, I can get the two edges touching. Now I had a little gap there that was running down to a nice joined up piece. So what I did was just put a little dob of wire on there, and then I've just walked the puddle along. So there's not even a lump where I put the piece of wire, I flowed it into the weld beside it. We might be able to do the same thing just in here. Little hole in there, a little bit of wire on it, and just walk it along. That's just magic. Work up a little low spot while I'm waiting. Like I say, not even that important at this stage, it was just a little bit of play. We only want the fender to sort of sit where it's supposed to. If we welded the bead line back together now, that'd be more than good enough, but might as well just have a little play with it while we're got the torch going, for want of a better word. Bit out of practice, haven't done this sort of welding for a while, so it's good just to have a little job like this to get my hand back in, so to speak. A little bit of damage here from where the rivets were in it. starting to get that just yummy 34 Ford shape to it. Looks like if we just keep going, it's going to line the bead line back up. That looks pretty nice on the bead line. If I can get them to sit together, we could just about spot across there. Naturally, there's a little gap there from the cutting disc, and the fact that someone's pushed a brake together in the past. So what I'm just going to do is put a little bit of weld on there, push the two together, and just see if we can just join them back together. It says no. Just like that. So looking at the wheel arch, the bottom of the arc doesn't look too bad, so we just keep tapping that around, working our 2 bits of metal. We should be close to the right shape. This old repair probably happened before I was born. Puts it all into perspective, doesn't it? Maybe next time someone's playing with this Fender, they'll go, "Oh, this old bloke that did this job, he must have made a reasonable job of it, it's still going." If you see, every little thing affects these cars. If you've got a split in the fender and you rock it, it actually changes the shape in and out here and down the back here as well. So that's why I like to get the integrity back into a panel before I use it for alignment, because you can think you've got it all working nicely and then find out that the fender's in the wrong spot. It's upset the alignment of the bonnet or the hood. Come on. And then you get nowhere. And I've heard stories about people cutting the edges of the bonnet to get them to line up, things like that. So I don't want to be doing that with this car. I want it nice. So this portion will probably get cut off and replaced, but like I say, for now we want it to be in alignment Now it's got a wired edge in there. The wire's obviously broken in there, but there's a bit of rust in there. It was burning out there. So it's not even a great weld there. So, and it's been repaired before. And you can see from the gap in there, that's how far the mismatch was out between the two panels. So if we so a bit of wire in there and weld up my gap from the cutting disc. There's another rotten patch in it just there where it's had that plate riveted on the back. So like I say, we'll probably come well out here, good metal, put a patch in there. Probably should just go a bit further and pick that piece up as well. That's where it's fatigued, where the fender brace used to be bolted into it. And but like I say, for now, for what we want to do, this is more than good enough. But I don't want to have any holes or sharp edges that I can cut myself on while I'm handling the panel, so I'll just run a bit of weld in here. The MIG would do a good job of just spotting this stuff up too, but we've got this one going. So. And there is some original crack line. Run a bit of wire in that too. A few little fatigue cracks showing up as I was heating it as well. Just from back in the day where it was rattling around. If only they could talk. This is a lump of weld that was from the old repair, so I'll just flow that in a bit. And there's a hole there that I want to play the game. That's the ticket. It's all about walking the puddle. Another little fatigue crack running over here too. There we go. Another one running down the edge of the bead line too. But I don't think I'm real worried about that today. So it's a case of settle, settle, settle here. Unleashing a can of worms, a bit of rust in the bead. There we go. Okay. So that's got my basic weld done, and all it is a temporary permanent for now because I just want to keep this fender in alignment. So I'll get the rest of these bumps, lumps and bumps sorted out on it, smooth it out a bit more. Not going to worry about the rivet holes because that'll be in the piece of panel that I replace. And if you look down here, it's got an old repair on here as well. It's just been a piece of metal wrapped around the fender and then bolted on with gutter bolts. So I'll have to get rid of all that, repair the cracks in the panel there and get it so I can bolt up to my running board. And then I'll get it so it bolts to the frame, repair this little inner guard panel here, and I'll do the same on the other side, and then I can start looking at the front and the grille. And once I've got the grille, the radiator, the fenders all in alignment, we can see how our hood sits against the cowl. The other side's pretty good for just a drop on, so I've got no real worries. I'm pretty certain it's all just going to work, but this is just one of those things. It's what makes the difference between having a really nice car that you can work your way through, and when it comes time to pull it apart and paint it, you know that you can detail all the parts and put it back together with no dramas, and we'll have it back to how Ford intended it to be when it was brand new. That's it, guys. We'll catch you next time round. I'm Rob Teal. Thanks for watching.